in example number 3, we're given a kite. And then it says, what is the most precise classification of the quadrilateral formed by connecting the midpoints of the sides of this kite? So my plan is to find those midpoints, which you can see I've done in the bottom right corner of your screen, and then I'm going to connect them and try and determine what type of quadrilateral I've created. So I found all 4 midpoints and I labeled them A, B, C, and D. And then I connected those 4 points, which are the green points, and it looks to me like it's a rectangle. So some of you may be tempted to say, oh, this is a rectangle, write that down, and be done. And you might be right. But if one of those sides is even slightly off by 0.1 centimeters, then it's not going to be a rectangle because one of the sides will be longer than its opposite side. So instead, what I'm going to try and do is think, okay, it does look like a rectangle. What are the things about a rectangle that are special? And I go to its definition. It has to be a parallelogram, and it has to have right angles. So, like the previous examples, there are lots of ways to show it's a parallelogram. The diagonals bisect, the opposite angles are the same, the consecutive angles add up to 180, the opposite sides are parallel. But the part about 4 right angles, there's only one way to do that. The only way to show with coordinates that something is a right angle is to show that it's perpendicular. And the way to show perpendicular is showing negative reciprocals for slopes. So I'm going to do a plan where I find the slopes of AB, CD, and see if they're the same to see if they're parallel. And I'm going to find the slopes of AC and BD to see if they are parallel. I said those backwards though. It would be the slope of AD and slope of BC. I apologize. So I want to show if the opposite sides are parallel. And by showing parallel, I'll be able to look at the same numbers and see if I have right angles. So let's start by finding some of these slopes. The slope of AB is the y minus the y, so it's going to be 2 minus 2 over negative 2 minus 4, which is 0 over negative 6, which is a slope of 0. The slope of CD is going to be the points, the y minus the y, so negative 2 minus negative 2 over negative 2 minus 4, which again is 0 over negative 6, or 0. So with that, I've shown that the slopes are the same, so these in fact are parallel. But that could be a trapezoid if only one set of sides are parallel, so I'm going to find the slope of AD. So the slope of AD, I look at my coordinates, would be 2 minus negative 2 over negative 2 minus negative 2, y minus y over x minus x, which is equal to 4 over 0, which is an undefined slope. But that's okay. If the other one comes up to be undefined as well, then I'm still the same, and those would be parallel. So I find the slope of BC, so it's going to be the y minus the y, 2 minus the negative 2, over the 4 minus the 4, which is 4 over 0, which again is an undefined slope. It's okay for both of them to be undefined. What I'm trying to show is that they're the same. So since these two are the same, those are definitely parallel. So what I have managed to show is that ABCD is a parallelogram. Because both pairs of opposite sides are parallel. Now the question asked me to find the most precise classification. It's definitely a parallelogram because I have 2 sets of parallel sides. But if the sides are the same length, then it's a rhombus, which I can clearly count the sides are not the same. AD has a distance of 4 and AB has a distance of 6. So it's not going to be a rhombus. But if those angles, which do appear to be right angles, are there, then it could be a rectangle. So what I need to show is that my slopes are negative reciprocals. So I'm going to try and show that AB is perpendicular to BC and AB is perpendicular to AD. And looking at my slopes, I have that. You need to remember that a slope of 0 is like 0 over 1, and that's my slope of AB. The slope of BC is undefined, or 1 over 0, and you could think of this as negative 1 over 0, and it would still be undefined. So what we have here is negative reciprocals as slopes. And since I have negative reciprocals as slopes, that means those are perpendicular. So if AB is perpendicular to BC, that means I can put a right angle in here. And if it's perpendicular to AD, I can put a right angle in here. So I've shown that I have those negative reciprocal slopes. Well, what I also need to show is that CD is perpendicular to AD and that CD is perpendicular to BC. And for the same reasons, the slope of CD again is 0 over 1, then the slope of AD is undefined, which we could write as negative 1 over 0. Again, we have this idea of negative reciprocals. And this is the only way to show right angles, is with those negative reciprocals as their slopes. So since those are perpendicular, I can go ahead and put a right angle in along the line DC. So I've shown using the slopes that I have a parallelogram, and I've shown using the slopes that I do have right angles. And that is the definition of a rectangle. And if I had more room, I would write this out in words, but my explanation is ABCD is a rectangle because it is a parallelogram with 4 right angles. And all of my work shows that that is true and justifies it, so I'm finished. Don't be afraid of all of this work and this writing. It is necessary to do the formulas, to show the slopes or the distances or the midpoints so I can see what you're working on. Try the examples in your workbook and see me if you have any questions. Good luck.